All right, continuing onward, we are, I think, chapter 12. Chapter 12. Oh, and heads up, I'm trying to do something new. Some people have complained that when the letters are behind me, you can't really see anything. So I made myself a little translucent. Kind of feel like a ghost. Anyway, chapter 12. An I/O project building a command line program. This chapter is a recap of the many skills you've learned so far and an exploration of a few more standard library features. We'll build a command line tool that interacts with file and command line input/output to practice some of the Rust concepts you now have under your belt. Rust speed, safety, single binary output, and cross-platform support make it an ideal language for creating command line tools. So for our project, we'll make our own version of the classic command line tool, grep. Globally, search a regular expression and print. In the simplest use case, grep searches a specified file for a specified string. To do so, grep takes as its arguments a file name and a string. Then it reads the file, finds lines in that file that contain the string argument, and prints those lines. Along the way, we'll show how to make our command line tool use features of the terminal that many command line tools use. We'll read the value from an environment variable to allow the user to configure the behavior of our tool. We'll also print error messages to the standard error console stream, standard error, instead of standard output, standard out. So, for example, the user can redirect successful output to a file while still seeing error messages on screen. One Rust community member, Andrew Gallant, has already created a fully featured, very fast version of grep called ripgrep. By comparison, our version of grep will be fairly simple, but this chapter will give you some of the background knowledge you need to understand a real-world project such as ripgrep. Our grep project will combine a number of concepts you've learned so far. And they have the bullet points here. We have organizing code, using what you learned in modules, chapter 7. Using vectors and strings, collections, chapter 8. Handling errors, chapter 9. Using traits and lifetimes where appropriate, chapter 10. Writing test, chapter 11, which we just went over. We also briefly introduced closures, iterators, and trait objects, which chapter 13 and 17 will cover in detail. Okay. Looks like we're going to make a toy version of grep. Understood. Accepting command line arguments. Let's create a new project with, as always, cargo new. We'll call our project mini-grep to distinguish it from the grep tool that you might already have on your system. So cargo new, mini-grep, creates a new binary, cd into it. I already have it. So I created that project just a second ago, and here it is. So we can close this. Here is my mini-grep. The first task is to make mini-grep accept its two command line arguments, the file name and string to search for. That is, we want to be able to run our program with cargo run, a string to search for, and a path to a file to search in, like so. And they have the example, cargo run searching string example file .text. So here's the run that we used to run the program. Here's the search string, the string that we're going to be looking for, and here's the text file. Right now, the program generated by cargo new cannot process arguments we give it. Some existing libraries on crates.io can help with writing a program that accepts command line arguments. But because you're just learning this concept, let's implement this capability ourselves. And here we go. Reading the argument values. To enable mini-grep to read the values of command line arguments we pass to it, we'll need a function provided in Rust standard library, which is standard environment args. This function returns an iterator of the command line arguments that we're given to mini-grep. We'll cover iterators fully in chapter 13. For now, you only need to know two details about iterators. Iterators produce a series of values, and we can call the collect method on an iterator to turn it into a collection, such as a vector, containing all the elements the iterator processes. Iterators produce a series of values, and we can call the collect method on an iterator to turn it into a collection, such as a vector, containing all the elements the iterator produces. Using the code in listing 12-1, which I'm guessing is this, yep, to allow your mini-grep program to read any command line arguments passed to it and then collect those values into a vector. And let's see how to do this. So we have the import statement, so we use standard library, environment variables, and then in our main, say let args equal environment variables args, which popped up, and we do a dot collect on it so we can make it into a vector. I think that's correct, and then we want to print out the args. So if I'm correct, this is all we need to do, and then from here we should be able to see the things that we passed in. So cargo run something, and we can close this, and it did not compile mini-grep. Do I need to explicitly put the type? Didn't think I needed to. Let args vector string cannot infer the type. Oh no, it worked the second time. So yeah, that's something to note. So for args and collection, they cannot infer the type, so we have to explicitly put the type for args, which is a vector of strings. Understood? First, we bring standard environment module into scope with a use statement so we can use its args function. Notice that the standard environment args function is nested in 2 levels of modules. As we discussed in chapter 7, in cases where the desired function is nested in more than one module, it's conventional to bring the parent module into scope rather than the function. By doing so, we can easily use the other functions from standard environment. It's also less ambiguous than adding use standard environment args and then calling the function with just args, because args might easily be mistaken for a function that's defined in the current module. So what they're saying here is they're just noting that the general practice of if you need to use something or import it from a module and it's nested a couple levels deep, then you always import the parent module instead of the actual function that you need because it's less ambiguous. That's the common practice in Rust. And they explain that in chapter 7. They're just going over it again. The args function and invalid Unicode. Note that the standard library environment args will panic if any argument contained invalid Unicode. If your program needs to accept arguments containing invalid Unicode, use standard environment args_os instead. That function returns an iterator that produces OS string values instead of string values. We've chosen to use standard environment args here for simplicity because OS string values differ per platform and are more complex to work with than string values. So just a summary of what they're saying here is we're using standard library environment args, and they work directly with strings. However, if you're writing a command line program that's going to take in things that are not valid Unicode, then you need something that is not strings. And they have OS strings, which can seemingly deal with that. But in terms of your command line application, instead of using environment args, you have to use environment args_os. And then the return type would be OS string. On the first line of main, we call environment args, and we immediately use collect to turn the iterator into a vector containing all the values produced by the iterator. We can use the collect function to create many kinds of collections, so we explicitly annotate the type of args to specify that we want a vector of strings. Although we very rarely need to annotate types in Rust, collect is one function you do often need to annotate because Rust isn't able to infer the kind of collection you want. Okay, this is an explanation of why we had to annotate explicitly that args is going to be a vector of strings. And the reason is, when we call collect, collect can turn things or return many different types. And because it can turn many different types, the compiler cannot infer what type you want. Thus, we have to explicitly put the type so that it knows which type of collection to return back to us. That makes sense, and that's probably covered in the iterator chapter. I think that's what, 17, 13, one of the two. Finally, we print the vector using the debug formatter and colon question mark. Let's try running the code first with no argument and then with 2 arguments. So I already ran the code with 1 argument. When you run it with no arguments, the first argument typically in a command line program is the name of the program. So that's what you have here, right? And then when you run it with 2 arguments, you see the name of the program and then your first argument and then your second argument. That's what they want to show. And when we ran it, we have the output still here, the name of the program, and the argument I passed in. Notice that the first value in the vector is target debug mini-grep, which is the name of our binary. This matches the behavior of the arguments list in C, letting programs use the name by which they were invoked in their execution. It's often convenient to have access to the program name in case you want to print it in messages or change behavior of the program based on what command line alias was used to invoke the program. But for the purpose of this chapter, we'll ignore it and save only the 2 arguments we need. So what they're saying here is that they're covering what I said, which is the first argument in command line program is the name of the command that you are running. And they gave some reasons for why it is, like historical reasons, but in terms of this program, it is not needed, so we're going to ignore it. Saving the argument values in variables. Printing the value of the vector of arguments illustrated that the program is able to access the values specified as command line arguments. Now we need to save the values of the 2 arguments in variables so we can use the values throughout the rest of the program. We do so in listing 12-2. And here is the program. So what they did was they took the first argument and saved it to query, and the second argument saved it to file name. Which we can do that right now. So we're going to say let query be equal to a pointer reference to args, because you just need the value. And we can let file name be the same thing, because we just need the value of file name. We don't need to mutate or anything like that. Args, second one. And then we're printing out that information. So repurpose this, searching for print line in file and this is no longer args, this is supposed to be query. So earlier when I ran the program, I ran it with 1 command. Given that we need both a query and a file name, we have to run it with at least 2. File name, file something, yeah, thing. So searching for something in file something. I am curious to see what happens if we run it with just 1. It should burn, fire, and it looks like it panicked. Yeah, that makes sense. It should panic because it's accessing an index in an vector that doesn't exist. Yeah, definitely should panic. Cool. And just do that again so we have good output right there. Moving on. As we saw when we printed the vector, the program's name takes up the first value in the vector's arguments, arg0. So we're starting at index 1. The first argument mini-grep takes is the string we're searching for. So we put a reference to the first argument in the variable query. The second argument will be the file name. So we put a reference to the second argument in the variable file name. We temporarily print the values of these variables to prove that the code is working as we intend. Let's run this program again with the arguments test and sample text. Sure. Running it again with test and sample dot text, and searching for test in file sample text. Great, the program is working. The values of the arguments we need are being saved into the right variables. Later, we'll add some error handling to deal with the certain potential erroneous situations, such as when a user provides no arguments. For now, we'll ignore that situation and work on adding file reading capabilities instead. Alright, so what they're saying here is, yes, we got this working. We have our variable names, but there are also edge cases, like when somebody runs your command and has nothing in it, passes no arguments. And then, like you saw what I did it earlier, your program will panic. You don't want that to happen. They acknowledge that, but right now we're going to ignore that situation, and the next section goes over file reading capabilities. That being said, that's the end of this video. Hope it was entertaining. Hope you learned something. If you like it, subscribe. Outside of that, peace.